Hello, math students. Welcome back to our module on percent and proportional relationships. This is lesson 2, and it is called mixed numbers. All right, so our goal for today we will understand why we change mixed numbers into fractions greater than 1. In the past, you may have been taught or you might be familiar with the words improper fraction. And improper fraction is the same meaning as fractions greater than 1. And the reason that we're calling them fractions greater than 1 is because that's exactly what they are. Is it's a whole number combined with a part of another number, so it makes them larger than 1. All right, so the question is, what does a mixed number really show us? Okay, under the things to know, I actually made the mixed number rather large under the things to know section because this is what we're going to be talking about today, and I need to make sure that you know all the parts. So this part right here that is a large 2, that is the actual number of wholes. So this would be a whole number. Okay. And then this part over here is actually a fraction, meaning that it's part of another number. So this is the fraction. And when you combine a whole number and a fraction, it makes a mixed number. Okay, so a whole number combined with a fraction is a mixed number. So then the thing that I want you to think about during this little discussion about mixed numbers is how many pieces make a whole. Okay, and so what we need to look at in order to determine this is the denominator. The denominator answers this question. And so basically, in order to understand that it is the denominator that answers this question, I'm going to go over that with you so that you can understand it. To understand mixed numbers, we can draw pictures of them, and this is really, really helpful until you get the complete idea of what a mixed number is. So when it says that we have 2 wholes, that means we have 2 complete whole numbers, all right? And when we said that the denominator answers this question, that means that we have 2 whole complete numbers built out of the denominator. So if I draw a square, that's 1 whole square, and this is another whole square. But the way we know it's whole is if we divide it into 4 equal pieces, it means that we have all of these pieces accounted for. So that means that's how many we have. So 2 wholes using pictures looks like that. Then we're going to also draw a picture of 3/4, and it says 3/4 of a whole. So we have to draw 1 more whole piece, except this time we only have 3 out of the 4 because that's what it says on the fraction. So we actually only have this, this, and this. Okay, so now when we combine those together, because this is a mixed number is a whole number combined with a fraction. So here are the pictures of the whole number and the fraction. All you have to do is count how many pieces you actually have. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's where 11/4 comes from, because we have 11 out of the 12 entire pieces, because when you have 12/4, that's what gives you 3, but we don't have 12/4, we only have 11/4, so that tells us that we have 1, 2, 3, 4, that's 1, 1, 2, 3, 4, that's 2, and 1, 2, 3 out of the 4, so it's 2 3/4. So this picture right here is exactly what that number is, but it's also, if you pay attention to what you're counting, it's also this number right here, because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces out of the 4 that is the denominator. And so that is how you can draw pictures to help you understand what you're actually dealing with, okay? So we would like to try it again with a couple more just to make sure that you have complete understanding of what we're doing. So let's try this one, 3 2/5. So remember the question that it was asked, how many pieces make up a whole? Well, the denominator tells us. So in this problem, our denominator is 5, so that means we have to have 5 sections. So if I have 1 whole, and then I go 1, 2, 3, 4, 5, that makes 1 whole. Then I have another whole, 1, 2, 3, 4, 5, and I make another hole. 1, 2, 3, 4, 5, and then on the next one, I only have 2 out of the 5. So 1, 2, 3, 4, 5, and now I color in what I have. So I have all of this one colored in, right? Because it says that I have a whole piece right there, so that's one hole. Here is 2 holes colored in. Here is 3 holes colored in, and then I have 2 out of the 5 of the next hole. So 1, 2. And that's all I get to color in, because that's what this fraction, or this mixed number is telling us. We have 3 whole pieces and 2 out of the 5 of the next. And so now I can turn this into a fraction greater than 1. And so the fraction greater than 1 for this one would be, count what you have colored, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is 17, and the denominator stays the same, so it would be 17 fifths. Okay? And that's how you change the mixed number into a fraction greater than 1, or another name that we call it is a mixed number. Okay? So not too bad, right? Some of you are probably thinking, well, why is she making us use pictures? The reason that I'm making you use pictures is because pictures allow us to see it so that we fully understand. All right, so let's try the next one. The next one says 4 2/7. So that means that I need 4 whole pieces. So 1, 2, 3, 4, and I'm supposed to split those into sevens. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there's those 4. So we have to color in each section because I have 4 holes. So coloring in all of them so that I have 4 whole pieces. Okay, almost there. 4 whole pieces. Done. Okay, and then it says I have 2 out of the next 7. So 1, 2, 3, 4, 5, 6, 7, and I only have 2 of them colored in this time. So now we have to write what we have. So we have 7, 14, 21, 28, 29, 30. And so now this fraction greater than 1 would be 30, and the denominator always stays the same, so 37. And we have a picture that matches. Okay? So, starting to make sense, starting to feel more comfortable with this, I hope. So let's do this one together. I have 2 holes, and this time it says there are 8 sections in each one. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I have to color all of those in because it says I have 2 holes. So coloring these guys in, coloring these guys in, so that I have 2 whole pieces. And then I have 5 out of the 8 on the next one. So 1, 2, 3, 4, 5, 6, 7, 8, and I have 1, 2, 3, 4, 5 colored in, right? And then I have to count what I have colored. So there's 8 here, there's 16, 17, 18, 19, 20, 21. So this one would be 21 colored pieces, and the denominator always stays the same, so it would be 21 eighths. Okay? So I hope you're starting to get the pattern. I hope that you're starting to understand how these models can actually really help you see how to turn a mixed number, how to turn a mixed number into a fraction greater than 1. Just to make sure you've got it, make sure you're paying attention, make sure you know what you're doing, I would like you to do this one right here by yourself, okay? And that's what we'll be looking for when we do a check in the morning when we see you, okay? So going back to our goal, today we will understand why we change mixed numbers into fractions greater than 1, also known as improper fractions. The question that I wanted you to think about is, what does a mixed number really show us? A mixed number really shows us all the parts that you actually have, including the whole parts that you have and the fractions of the next part that you have. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye!